So the basic principles, the basic rules we have seen, the product rule we have seen, the summation rule we have seen. So for example, you know what is a summation rule. If an experiment, either you can have an outcome or m outcome, and they do not overlap, they are disjoint. If they do not overlap, this is very important. If there is no overlap, then you can add. Okay, so basically if two things are disjoint, then you can directly add. If two set are disjoint, if two set have nothing common, then I can say that this will happen. The cardinality of A union B will be cardinality of A plus cardinality of B. Okay, so this we have seen, the summation rule. So remember T1, T2, T3, they should not have anything common. They should not have any common, not have any way common. Okay, so there should be no way common. So this is the idea. Okay, so means this okay, either to complete this task T, if you want to complete this task T, then you can either do T1 or you can do T2 or you can do T3. And if they are disjoint, this okay, these n1 ways, these n2 ways, these n3 ways, if they are disjoint, then I can say that okay, you can directly add. Okay, so answer will be n1 plus n2 plus n3. This is your summation rule, and we have also seen what is the product rule. Okay, so this is the idea. You can notice in a product rule we have sequence of tasks, correct? We have T1 and T2 and T3, so we have a sequence of tasks. In summation rule we have alternative, like either you can do T1 or you can do T2 or you can do T3. So in the summation rule we have alternatives. Okay, either you can do T1, you don't have to do T2, you can do T1. Once you do T1, automatically your task will be done. But in the product rule we have sequence of tasks. You have to do T1 and you have to do T2 and you have to do T3. So this is the idea. Now let's solve this question. See, the combinatorics is very important, you know. Okay, the combinatorics means basically counting. Combinatorics, I can also say that it is basically the set of counting principles. Now you can notice one thing, that how hard it is for someone to guess your pin code. Can anyone tell me how many pin codes are possible for your ATM card? You have 4-digit pin code, right? Okay, so can anyone tell me how many pin codes are possible? This is the question. How many pin codes are possible? So what that answer will be? How many pin codes are possible for our debit card? So we need four digits. Okay, you need 4 digits. Now, so first digit you need second digit, you need third digit, you need fourth digit. Okay, so this is the idea. You need all of them. You need all of them. So you need T1 and you need T2 and you need T3 and you need T4. So for first digit you have 10 choices. For second digit also you have 10 choices. See, for first digit I have 10 choices. Whatever I put here, for the next also I have 10 choices. Whatever I put here, again I have 10 choices. Whatever I put here, again I have 10 choices. Okay, so finally, because of product rule, I can say 10 to the power 4. These many pin codes are possible. So remember, 10,000 pin codes are possible. Is this clear? So for your ATM pin, for your debit card, 10,000 pin codes are possible. So if someone want to guess your pin, then okay, one of those 10,000 he will have to guess. Okay, so anyway, this is very hard, right? If you have 6, then there will be 10 lakh. Okay, if there are 6 digits, then there will be 1 million. 1 million means 10 lakhs. Okay, so that is the idea. So this is a hard thing, you can notice. Let's solve this question. So what will be the answer for this? How many license plate you have? Two letters followed by 3 digits. How many license plates? So the answer will be first. So the answer will be our option A. Option A will be the answer. And when option B will be the answer, tell me what should I do in the question? What should I do in the question so that option B will be the answer? If I write no repetition, no repetition of letters, comma digits, no repetition of letters, comma digits, now the answer will be option B, because now you don't have any repetition. So here the answer is very simple. Here, because you want two letters followed by 3 digits. Okay, so 2 letters followed by 3 digits. So I can say 26, and 3 digit means 10. So finally answer will be 26 power 2 and 10 power 3. And here, because you have no repetition, there is no repetition. So because there is no repetition, so here you want a letter. here you want another letter, here you want digit, here you want digit, here you want digit. So for the first letter, we have 26 choices. But now, if whatever I put here, now only 25 choices are there. Now, for this, we have 10 choices. Whatever I put here, I cannot reuse. I cannot reuse because I cannot repeat. No repetition. Okay, so I cannot reuse. And finally, 8. So the answer will be option B. Okay, let's move on. This is your ISRO 2014 question. What will be the answer? ISRO 2014 question. The number of bit strings of length 8 that will start with 1, okay, and end with 00, or end with 00. So this actually we have already done in the last class. So what you want 8 length bit strings. So this is what you want. You want 8 length bit strings. Okay, and remember, either they should start with 1. Either they should start with 1. Okay, this should happen, or they should end with 00, or this should happen. Correct. Now remember, are they disjoint? So you tell me, are these two disjoint? So this is your main task. I can say this is your main task T. Okay, so this T1 comma T2, can I say they are disjoint? They are definitely not disjoint. So they are not disjoint. What is common between them? Okay, what is common between them? Let's find out. What is common? Starting with 1 and ending with 00. This is common, right? Okay, so these things are common. Now starting with 1, how many such bit strings we have? Okay, bit strings starting with 1. Bit strings starting with 1. So your bit string should start with 1. 8 length bit string must be there. You must have 8 length bit string that should start with 1. 1, 2, 3, 4, 5, 6, 7. Okay, this should start with 1. So you should put 1 here. Now there is no choice. I can say there is only one choice here. There is only one choice here. Okay, so you have to put this 1 here. Now for the remaining positions, I have two choices. For all the remaining positions, I have two choices. For all the remaining positions, there are two choices. So finally, start number of bit strings, 8 length, number of bit strings that start with 1, that will be 2 power 7. Okay, so that will be 2 power 7. So I can say here, I can say this will be 2 power 7. Ending with 00, that will be 2 power 6, right? And how many these are there? Okay, means these how many we have? So ending with 00, you know, if you want to ending with 00, if you want to end with 00, so there is no choice. This should be 0, this should be 0. For the remaining, you have choice. For the remaining, you have two choices. You have two choices. So that will be 2 power 6. This will be ending with 00. Ending with 00. And now, how many these we have which start with 1 and with 00? Okay, start with 1 and with 00. So for them, we have total 5. I can say 2 power 5 because it should start with 1. This is fixed. This is fixed. The remaining have two choices. The remaining positions have two choices. So this will be 2 power 5. So finally, answer will be what? Answer will be 2 power 7 plus 2 power 6. Remember, when I do 2 power 7 plus 2 power 6, then these common things, these bit strings, which start with 1 and they end with 00, these bit strings I have counted 2 times. This type of bit strings, all these bit strings, okay, so this type of bit strings I have counted 2 times, so I should subtract them 1 time. So I can say that will be 2 power 7 plus 2 power 6 minus 2 power 5. So your answer will be, that will be 128 plus 64 minus 32, that will be 128 plus 32, and that you can just find it out, that will be 160, I guess. Okay, so the answer will be option C. This is your GATE exam, this is your ISRO exam question. Let me tell you one thing. If you want to crack ISRO exam, you don't have to do anything. All the ISRO exam questions which will come in the ISRO exam, they are already present in the market. I can promise you one thing, that once you give the next ISRO exam, once you give, after that you check all those questions. almost 50% are already available on GATEOverflow website. Almost 50% or more than 50% questions are already available on GATEOverflow website. Okay, because most of the questions that they will ask, almost all the questions that they will ask, these ISRO people, they will ask, okay, they will ask from either previous exams like GATE exam, NAT exam, GATE exam, this or many other university assignments and all. So this is the idea. Tell me what is the answer for this. Suppose variable names in programming language can be either a single uppercase letter. So what will be the answer here? Variable names in a programming language, there is a programming language, can either be a single uppercase letter or an uppercase letter followed by digit. So how many possible variable names you can create? So the answer is very simple. Remember, variable name, the question is saying that variable name can either be a single uppercase letter, either it can be a single uppercase letter. Okay, single uppercase letter, either it can be a single uppercase letter. So I can say either it is a single uppercase letter. Okay, so I can say uppercase letter, or this can have two things. Okay, one digit, uppercase letter followed by one digit. So this is the idea. So here we have or. Tell me, these two, are they disjoint? These two, are they disjoint? This T1 and T2, are they disjoint? Yes, they are completely disjoint. T1, T2, they are disjoint. Okay, so how many ways for T1? So here the answer will be 26. There are 26 ways for T1. And how many ways for T2? So here we have 26, here we have 10. So these many ways for T2. And because they are disjoint, T1 comma T2, they are completely disjoint. You can notice T1, T2. You can notice that they are disjoint, T1, T2. They are disjoint. So what I can do, I can add. So the answer will be 26 plus. Okay, so the answer will be 286. This will be the answer. Okay, next, what is the answer for this question? 4 length bit strings start with 101 or end with 101. 4 length bit strings. You have 4 length bit strings which start with 101 or end with 101 or end with 001. Are they disjoint? So tell me, either you should start, remember, either you should start with 101, either you should start with 101 or you should end with 001. Are they disjoint? This T1, this T2, this T1, this T2, are they disjoint? Yes, of course they are disjoint. Okay, because nothing is common. This T1, T2, these are, you can notice, these are disjoint. These are disjoint because there is nothing common. You can just check it out. Can you have something common? Can you have something common? Like these are starting with 101. These are ending with 001. Can you have something common? So no, you cannot have something common. So finally, because they are disjoint, so either you can do this or you can do this. There is or. So okay, for this you have only two. There are only two ways because this is starting with 101. So there are only two ways, and for this also there are only two ways. So finally answer will be what? Okay, so final answer, that will be 2 plus 2. Answer will be 4. So very simple. So this is the idea. So remember, can these two things happen together? These two things, can they happen together? These two things, like starting with 101, ending with 001, can they happen together for a 4 length bit string? So we have 4 length bit string. For a 4 length bit string, these two things can never happen together. Okay, can they happen together for 6 length bit string? Like the same question, if I ask you for 6 length bit string, then what will be the answer? The same question, let me ask for 6 length bit string. The same question. Now what will be the answer? 6 length. Now there is something common. Okay, now you can notice that either you can start with 101 or you can end with 0, 0, 1. Now they have something common. Now this T1 comma T2, they have something common. So there is OR. There is OR between them, but there is something common. And what is common? Common means common means common means it should be here and it should be here. Common means it should start with 101 and it should end with 001. Only this string is common. So only one string is common. So how many we have here? So we have 2 power 3 here. We have 2 power 3 here. And this only one string is common. Only one common string. So this one common string we have. So final answer will be, your answer will be 2 power 3 plus 2 power 3 minus 1. So answer will be 15. Okay. So very simple. So like this, you can do all these questions. These are very simple. Now let's see a question. But before that, let me just tell you coin flip. You know what is coin? How many sides a coin has? 2 sides, right? So for any coin, there are 2 sides. One is, this side is called tail and this side is called head. Okay, so basically head and tail. So these are 2 sides. Okay, this is how coin is tossed anyway. Okay, anyway, this is just because this coin is very important for probability. In probability subject, this coin, dice, all these things are very important. So tell me, how many outcomes are possible? How many outcomes are possible when flipping a coin n times? You have a coin, there is a coin with you, and this coin you are flipping n times. Then how many outcomes are possible? Like see, if you toss it 2 times, then first time you can get head, second time you can get head. First time you can get head, second time you can get tail. First time you can get tail, second time head, or both time tail. So my question is, how many outcomes are possible when you flip a coin n times? Okay, so you can notice that you are flipping a coin n times. You are flipping F1, flip 2, flip 3, flip 4, and so on, flip n. So tell me, for first flip, how many choices you have? For first flip, how many choices are there? For first flip, there are 2 choices. There are 2 ways. I can say there are 2 results. There are 2 outcomes. There are 2 outcomes possible. Okay, what are these 2 outcomes? Either you can get a head, or you can get a tail. So when you are flipping for the first time, this is F1. F1 means flipping for the first time. So there are 2 outcomes possible. Okay, here also 2 outcomes possible. Here also 2 outcomes possible. Here also 2 outcomes possible. So for each, we have 2 outcomes possible. So finally, tell me, we have to flip n times. So we have to flip F1 and F2 and F3. So we have to do this. So the answer will be what? So the answer will be 2 power n possible outcomes. 2 power n possible outcomes. Okay, so this is the answer. So quite simple. Let's see the next. How many subsets of this set are there? For this set, how many subsets we have? If you have a set like this, then how many subsets you can create? Now see, whatever set you create, consider this subset. Consider this subset. Like for example, let's consider this subset. Can you notice in this subset what is happening? In this subset, I can say one is present. I can say one is present. What is 2? 2 is absent. 3 is present. 4 is present. Right? Yes or no? Okay, so like this. 5 is absent. 5 is absent. And okay, n is also absent. So like this, you can understand. Correct? So whatever subset I give you, you can think like this. Whatever subset I give you, you can think like this. That 1 is present, 2 is absent, 3 is present, 4 is present, 5 is absent, 6 is absent. So you can notice 6 is absent, and so on, n is absent. So this is the idea, correct? Is this idea clear? So whatever subset I give you, for example, for this subset, what will happen if I give you this subset? If I give you this subset, for this subset, what you will say? For this subset, what you will say? For this subset, you will say that all are absent. So this is absent, this is absent, this is absent, this is absent. So for this subset, you will say like this. So this is the idea. I can say that for every element, we have two choices. Either it is present in the subset or it is not present in the subset. Okay, so this is your set 1 to n. This is your set. Now, when you create a subset, of S, so when you create, we are creating a subset of S. This is what we are creating. Okay, we are creating a subset of S. So when you create a subset of S, then every element of S has two choices. Correct? Okay, so every element has two choices. Either it can be present in this subset or it can be absent from this subset. So either it can be present or it can be absent. Similarly, this either can be present or this can be absent. Similarly, this either can be present or this can be absent. So every element has two choices. Either this element can be present or this can be absent. So very simple. So finally, how many subsets you can create? So number of subsets. So finally, what is number of subsets? So that will be 2 power n, because every element has two choices. For every element, we have two choices when you are creating a subset. Okay, let's see the next question. Is this clear? This we have also seen in the set chapter. Let's see how many functions we have from a set of m elements to a set of n elements. How many functions we have? So what is the answer? From a set, how many functions you have from set A to set B, where set A cardinality is m, set B cardinality is n. Okay, so this is given to you. So now how many subsets you can create? So remember, in this A, you have total m elements. So let's assume you have total m elements. And in this B, you have total, in this B, we have total n elements. We have total n elements. Now, you want to create a subset from, you want to create a function from A to B. Function. In function, tell me, in function, should I map all of them? Should I map all of them? Yes, I should map all of them. So I can say your task is to map 1 and map 2. So what is your task? So your task is what? Your task is to map 1 and, okay, so this is your task, map 1, map 2 and map 3 and so on and so on. Okay, and so on, and map m. Okay, so this is what you need to do. You need to map this. So to map 1, how many choices we have? To map 1, how many choices we have? To map 1, we have total n choices. We have total n choices. If you map to this one, if you want to map, so this one can map to any of these elements. So to map 1, we have n choices. To map 2, we have again n choices. We again have n choices. So for example, if you want to map 2, you can map it to anywhere. You can map it to anywhere. To map 3, again we have n choices. Again we have n choices. This 3 you can map to anywhere. This 3 you can map to anywhere. Like this, finally, like this, and so on. For every element, we have n choices. For every element, we have n choices. So I can say for this element, n choices. So for every element, we have n choices. Okay, so finally, what will be the answer? How many functions we can create? How many functions we can create? For every element, we have n choices. For this element, 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 n choices. So now you can just multiply them, because you have to map all of them. So finally, number of functions will be, that will be, okay, so I can say here, number of functions, that will be n power m. Okay, just multiply all of them, then you will get n power m. So this is the idea. Now tell me, which formula is correct? Which formula is correct? I am giving you two formula and you tell me which formula is correct. I am giving you two formula. Number of functions from set A to set B. What is that? So none of them is correct. These are just nonsense. Okay, so remember, these are just nonsense. These are just nonsense. The number of functions, that will be cardinality of B power cardinality of A. This will be the correct answer. Okay, so anyway, so okay, this is not a, I just wanted to tell you that this is nonsense. Okay, don't write like this. So if you have two set, for example, if you have a set, for example, A comma B, you have a set, for example, B, let's assume, then this does not make any sense. See, this thing does not make any sense. This thing is nonsense. This thing is nonsense. Okay, so the answer will be cardinality of B power cardinality of A. Okay. Anyway, this is not a trap. Don't worry. In the GATE exam, in any exam, they will not ask you this. This I just want to tell you. Okay, I want to tell you that you should have clear understanding that. Okay, so answer will be cardinality of B power cardinality of A. Number of elements in B power number of elements in A. Okay, this means this is nonsense. This is also nonsense. Okay, don't worry. In exam, they will not ask you like this. Okay, this is just for like I can say technical point. This type of thing is this type of things are called technicalities, right? This type of things are called technicalities. Like technically this is wrong, this is correct, technically this is wrong. Okay, anyway, so let's see this question. What is the answer? What will be the answer for this question? You have set A, set B. Cardinality of A is 3. Cardinality of B is 5. How many one-to-one functions from A to B are there? So from A to B, how many one-to-one functions you can create? So remember, in A you have 3 elements. In B you have 5 elements. Okay, and you want to create a one-to-one function. One-to-one function simply means that. So what this means? One-to-one function. This means that different elements, different image. It simply means different elements have different image. Different elements have different image. Okay, so for A, how many choices you have? For A, how many choices you have? For A, we have 5 choices. For A, we have total 5 choices we have. For A, this A can map to anyone. This A can map to anyone. Now, because I want one function, so for B, how many choices I have? So once this is done, now how many choices for B? Only 4 choices for B. For B, only 4 choices we have because B cannot map to 3. So B can map to 1. Now C cannot map to 1, C cannot map to 3. So for C, there are 3 choices. Okay, so finally answer will be what? We have to map A and we have to map B and we have to map C. So finally answer will be, the answer will be 5 into 4 into 3. This will be your answer. Correct? Okay, so very simple. So remember, one-to-one function means different elements have different images. Different elements have different images. So this is the idea of one-to-one function. Different elements have different images. Okay, anyway, let's solve this question. Now, what is the answer? From B to A, how many one-to-one function we have? From B to A, how many one-to-one function we have? So here the answer will be 0. Okay, there is number of functions I am asking. So the answer will be 0. How many functions are there from B to, how many one-to-one functions are there from B to A? So in B you have 5 elements. In A you have 3 elements. Okay, this is your B, this is your A. You want to define one function. Can you get one function? Can you get one function? No, you cannot get one function. Whatever you do, you cannot get one function. Okay, so there is no one function here. I can say that number of one function will be 0. Number of one function will be 0, and this you already know. Injective function exists if and only if injective function exists. Injective function exists if and only if injective function exists. Remember, injective function exists if and only if domain cardinality is less than or equal to codomain cardinality. Okay, domain cardinality is less than equal to codomain cardinality. Okay, so the cardinality of domain should be less than or equal to the cardinality of codomain. Then injective function will be existing. Okay, let's move on. So tell me the answer for this question. How many student ID with 3 letters followed by 2 digits, how many possible? How many student ID possible? 3 letters followed by, so that will be 26 power 3 multiplied by 10 to the power 2. And if duplication is not allowed, then this 26, 25, 24, 10, 9. Okay, if duplication is not allowed.